Welcome to the prerequisite chapter for pre-calculus honors. This video will be covering just graphing calculator features. In this class, oftentimes we will call your graphing calculator a grapher because not only can you do these things on your calculator, but you can do them with online graphing features as well. So instead of referring to just calculators, a lot of times we'll just say grapher. So a few of the things that we'll be going through in this video are key features or keys and kind of properties that you can use on your calculator, how to graph on your calculator. Specifically, we're going to focus on how to set a window when you're looking at specific graphs and what that means, and then how to find regressions or to find equations that fit a data set, and then how to solve equations and intersections and things on your calculator. So we're going to start off by looking for a few key features. And first, we're just going to go through and identify these buttons on your calculator. So the school recommends, and if you are a junior, sophomore, or freshman, you have to have this specific calculator, a TI-84. If you're a senior, you don't have to have this calculator, but we do highly recommend it because this is the calculator that we kind of use as our model. Now, you don't have to have the color edition, the CE edition, but since most students tend to have that, that is what I'll be using as our featured calculator today. Okay, if you have any Texas Instrument calculator, it should have these same keys in relatively the same place. So the first key that we're going to look for is this second key, and the second key is like shift. This key is what lets you use the features that are written above each key. So if you look at your calculator, it's usually blue or pink or red or some other color, and it's at the top left corner and it says second. Think of that as your shift key. So everything that's written in blue above your other keys, the way that you use that feature is by hitting the second key first. Okay, so to quit, you would do second mode. And because quit is written in blue, that's how you would access that feature. The next button that we're going to look for is the quit button, which I kind of spoiled. I already showed you where it is, right? So in order to exit out of a menu, if you're looking at a graph, or if you are making a list, or if maybe you are looking at additional functions that you can use, anything like that, if you ever want to go back to the main screen, the way you're going to do that is you're going to hit that second button, and then you hit mode, and what that does is it activates the key above it, which is quit. Next, we want to find the math button. Now, math does not have a special color, but it is relatively close to that second button. If you just go 2 down, there is your math menu. Now, when you access the math menu, it has features like changing your answer into fractions or decimals. You can do things like cube rooting or raising something to the third power, absolute value, rounding, minimizing or maximizing, finding a conjugate. But that's also where you find all of the features that you've hopefully seen before in geometry, such as permutations, combinations, and factorials. Okay, so the math key is where we have the extension of our math functions. Next key that we're going to look for is the stat key. And the stat key we'll be using later on in this video in order to calculate regressions and to create lists of data points. And stat is kind of in that top part of the calculator in the middle. So stat, right next to the arrow buttons, you'll see the stat button. And again, that's where you're going to put in data. So when we're looking at lists of numbers or lists of information and we want to put that into the calculator so that we can do a calculation with it or something like that, we're going to use that stat. Now, when we put in the information into the stat menu, if we want to use it, usually we'll have to do a calculation using a list of data that we entered. And so stat is where we're going to input the information. To actually use the information, a lot of times we have to use the list feature. So again, notice it's in blue writing above the key. So we have to hit the shift key, second stat. So in order to access the list, we have to do second Sorry, typing on a mouse pad, not the easiest. So second, and then stat. And then the last key that we're going to look for is this table key. So take a second, look through your calculator, see if you can find where it says table. Something that might help is to know that the buttons at the top directly underneath the screen of your calculator, the buttons at the top directly under the screen are used for graphing. So that's when you're looking at something visually on your calculator. So if I want to look at a table of features, a table of points, let's say, that's going to be up directly underneath the screen. Again, it's in blue, so in order to access that, we have to do second and then graph. I'm not going to try writing it again, but you should denote somewhere in your notes that to access a table of values, like your XY table that you draw when you're graphing, you need second and then graph. So these are some of the features and functions that we use very frequently throughout this course. So you want to become familiar with your calculator, know how to use it, be comfortable accessing these menus and knowing what they do. So I highly encourage you to spend some time just kind of playing with your calculator. Say, oh, I don't know what that means. Try it out. Try typing some numbers into things. You know, just play with it. That's how you get familiar with your calculator. Okay. So next, what we want to do is we want to actually look at how do we graph. So remember I said all of those buttons directly underneath the screen are used for graphing. So if you are given an equation, in order to graph it, first you need to put it into y equals form. What does that mean? Well, solving for y sets it in function notation. And the way that we're going to graph, at least for the first part of our semester, is using that function notation. And so what you want to do is you want to make sure that your equation is set up as y equals something, and then you're going to find the y equals button on your calculator. So take a second, see if you can find that y equals button. And many of you have probably used this feature before. It's at the top left corner of your calculator. So top left, directly underneath the screen, is the y equals button. Now the important thing when you're graphing, once you're into the y equals, you can just type out the equation. However, that's not the final step in order to view a graph. And so what I'd like to do is do this little experiment where I want you to see if you can graph the equation written at the bottom of the screen here, y equals 3x cubed minus 2x plus 12. And there's a couple little tricks to graphing this equation. So first we notice it's already in y equals form, so we don't have to solve for y. And when you're typing it into the y equals, our first trick is how do we get cubed? So I already mentioned you can actually access a cubed function if you go into the math menu. However, you don't have to go into that menu. You can also write 3x and use the exponent key, the little caret that points up. And that's directly underneath the arrows. If you look 2 keys below the arrows, all the way on the right side of your calculator, there's a little caret key. And then you're going to do 3. So I'm going to go ahead and swipe over to my calculator screen. Hopefully you can see that. I go into the y equals menu. I'm going to clear out the graphs that I had used previously. And I'm going to type 3x raised to the third power. Now next I want to subtract, but I don't want to subtract from the exponent, so I have to click the right arrow to take me out of the exponent. Minus 2x plus 12. Okay, so let's look back at the slide. So we typed in our y equals, and now we want to set our viewing window. Now, I usually start with our standard viewing window. So how do I look at our standard viewing window? And then what we'll look at next in the next slide is how do we change the window. So we're going to start by looking at our standard viewing window. And the way we do that is we go to zoom, that's the middle button at the top directly under the screen. And we have all of these options. We're going to go to the standard zoom. And that's option 6. You have a couple ways to access that. You can either press the number 6 or you can scroll down using your arrows to number 6 and hit enter. So as you get used to where all of these features are in your calculator, there are some shortcuts. You can just hit zoom 6 and it will always go back to that standard window. So I'm going to say standard, and then it will graph it. If you're not going to change the window, let's say you already know it's in the standard window and you just want to go straight from having the equation to seeing the graph, then you would hit that graph button. So if I'm looking at this and I say, oh, well, that looks kind of like a line, maybe a little bit curved, but that's all it looked like to me, is a slightly curved line. However, I know that if this is a cubic function, let me go back to this screen here, this is a cubic function, and I know that cubic functions should look something like this, with 2 arms, one going up and one going down. So what that tells me is that the window that we're looking at does not show me the whole function. Now, because those arms go out to infinity, I'm not expecting to see the endpoints of this function, but I would like to see the body, the kind of crucial, critical points of the function, which is where it has that little change from kind of the upper arm to the lower arm. Okay, so I'd like to see a window that has that in it. Now, if we look at this, plus 12 means that my graph was moved up by 12. Think about it as the y-intercept, right? It's higher, it's increased. And so what we're actually looking at in the window that we were just looking at is this part of the graph right here. And what I want to look at is this part of the graph over here. So how do I change the viewing window to see that part of the graph? Well, we said it moved up by 12. So a good thing we can start with is changing our y values. Instead of from negative 10 to 10, which is what we're looking at now, we'd like to see at least up to 12. So let's try changing our window from 0 to 20. And let's see if that helps. So we're going to go over here, and the way we do that is we hit the window key. Window. We don't want to change our x values yet. What we want to change first is our y values. And the reason we're changing those y values is because that plus 12 told us that our function goes up higher than we could see. And so let's change our y minimum to 0 and our y maximum to 20. And let's try that. So let's hit graph, and now we can see that looks like a cubic function. So that's what it means to change the window. Now, if I wanted to calculate something with this, or if I wanted to see it in more detail, notice I could even change the window to have my function spread out more horizontally. I could change the x values to be narrower. I could choose y values more close to the center. So I can kind of zoom in on this graph to see it more clearly. And there's a couple ways to do that. We can go zoom, and the second option is zoom in. The key here, though, is that it's going to zoom in wherever that little plus sign is blinking. And so if I want to zoom in on the middle, I have to kind of move that plus sign to where I want to zoom in. And this is the key that people sometimes forget, hit enter. So in order to actually zoom, I have to hit enter, and then it will zoom in. Okay, so if you don't need to specify a very specific window, but you just wanted to zoom in somewhere, that's how you can do it. Okay, I've gotten a little bit ahead of myself in the notes. On our next slide here, we talk about zooming in the standard window. So that was zoom 6, and it always sets the window to from negative 10 to 10 in the x values and negative 10 to 10 in our y values. And then we also talked about how you can change the window manually by saying, I want to look at this specific range of values in our x's as well as our y's. Now, we only change the y values, but you can do the same thing for x values. Okay. So we're going to be able to use this window feature again in our next example. And there's a lot of words on this next slide. So let's take it one line at a time. And we're going to look at finding a linear model. Now, I called this a regression earlier. That's another way of saying that you're finding this is linear, meaning a line. So you're finding the equation of a line that best fits with the data that you're given. Okay, so the first thing we have to do if we're trying to do this on a calculator is we need to tell the calculator the information that we know. And the way we do that is we're going to go into stat. So go ahead and in your calculator right now, go into stat. And the first option that you see should be edit. Okay, now if you have something on the screen already, what you'll want to do is go up so that, click up so that your L1 and L2 are cleared. Okay, so let me show you on the calculator here. We're going to go into stat. Our first option is edit. If I need to clear these, if they're already empty, don't worry about it. But if I need to clear this, I'm going to go up so that L2 is highlighted and hit clear. Do not hit delete because that will actually delete the list. You won't be able to type into L2 anymore. So hit clear and then enter. And then go over to L1 and we'll do the same thing. Up, clear, enter. If you accidentally delete a list, the way to restore them is you'll go to stat, and then the fifth option is edit, setup editor, and you hit enter. And what that will do, enter again, will just restore any deleted lists. So stat, edit. Now my lists are clear. So we're going to go back to the slide. And what we're going to look at here is we're going to type our Y1 as our years and Y2 as our money. So essentially we're calling this X and this Y. So we're going to go over to the calculator now. And I have a copy of the data that I'm going to start typing in. So 2005, enter. 2006, 2007, 2008, 2009, 2010. Okay, and then to type in our second column, our dollars now, we're typing 10.5, 11.3, hitting enter after each one, 11.9, 12.5, 11.9, and 12.4. Now, anytime you're typing into a list, a good thing to check just to make sure that you have all of the data typed in is to make sure your lists are the same length. Because these are making up ordered pairs, right? X is 2005 and Y is 10.5. If my lists are different lengths, then I have at least one that doesn't have an ordered pair. And so it'll give you an error message. Okay, so we typed in our data. Let's go back to the slide. Our next step is to exit. Okay, now the reason we have to exit is because we told the calculator the information. Now we want to use it. Okay, so we're going to go over here. We're going to second quit. And then we want, now that we put the information in, we want to be able to graph it. And so in order to graph this, it's not a function. So instead of going into the y equals, we're going into the stat plot. Notice it's above the y equals. How do we get to that blue writing? Second y equals. And then we're going to say stat plot 1 on. So I'm going to say enter, enter to turn it on. Okay, now I'm double checking this used list 1 and list 2. If you haven't used stat plot before, then your settings are already going to be defaulted to the correct settings. And so the shortcut is, if you go into the y equals, without having to go into the stat plot, and I'm going to go ahead and clear out my equation here, you can go up and turn stat plot on right here from the function menu. So that means if I'm graphing a function later and I don't want this scatter plot to show, I can turn the plot off from here as well. And all I'm doing is going up to highlight it, enter to unhighlight it, up to highlight it, enter, and now it's turned on. And what that means is it's just telling the calculator if you want to see those points on your graph or not. Okay, so now I'm going to go back to the slide so we can see the data. So now we can see the data. We turned it on so the calculator knows we want to see it. And now we need to set our window. Okay, so how do we choose a window to look at this data? Well, my X values range from 2005 to 2010. So I need to be able to see at least from 2005 to 2010. Now, I chose to look from 2002 to 2015. This is not the only window you could have chosen. You could have chosen from 2004 to 2011. But I will say you don't really want to look from 2005 to 2010 because then you'll have points that are on the very edges of your screen. So to get the best view, you want to make sure there's at least a little bit of margin around your data. Same thing for the Y values. I want to go from at least 10.5 to at least. My biggest number here is 12.5. So again, leaving some margin, I chose to go from 8 to 16, but that's not the only option. You could have chosen to go from 10 to 13, but I like to give myself a little bit more room around the sides of my data points. So how do I do this? I'm going to go back to the calculator. I want to change the window because I have specific numbers that I want my window to be. My X values, I want to go from 2002. My X values maximum, the biggest X value I need to see is 2015. Don't worry about the X scale. That tells me where the tick marks are on the calculator. The Y minimum, I want to be 8. And the Y maximum, I want to be 16. So now when I graph this, I can see the data points that I had entered. Okay, your graph should look like this now. It might not be blue, it might be a different color, that's fine if it's black, if it's circles instead of squares, but the points should look like this. Okay, so that's graphing a scatter plot. We want to go one step further. We want to know what line would fit the best through this scatter plot. So if I go back to the slide, if I were to guess, I would draw a line kind of like that, fitting through the scatter plot. But what we want to find is we want the exact best fit line. And luckily, the calculator will do all of that calculation for us. Okay, and the way we do that is we're going to go into the stat menu. We're going to go over to the math column, and we're going to calculate what's called a linear regression. So it says, I see these points. I think they look like a line. That's the linear part. And then I want to take those points and find the line of best fit, which is called a regression. Okay, so here we go. Into the calculator, we're going to go stat, calculate. Option 4 is the linear regression. Okay, and now I'm going to calculate with list 1 and list 2. And we want to store this in a variable. So I'd like to store this so that I can graph it. And if I want to store it, I want to store it as a function. And so we're going to use the vars menu. This is a new button we haven't used before, vars, for variables. So I want to store it as a variable. Specifically, I want to store it as a function. That's a y variable. So over to yvars and as a function. Enter. We'll list it as the first function. That's fine. And then calculate. Now, the instructions that I have written down in the slide are if you don't have the color edition, because I'm showing you a CE model. I also want to give you instructions if you have the 84 plus without the color. So if you don't have the color edition, it's the same steps as are written on that slide. Okay, which I'm going to show you. If you don't have the color edition, the only difference is that you don't have that special menu that pops up when you go to calculate the linear regression. And so what you do is when you go into stat, calculate, linear regression, instead of coming up with this menu, what it will do is it will put this into your screen. Something like that looks like linear regression just up to here. And so you have to type in the last part. So you'll type in linear regression, ax plus b, That's what will show up when you go into the stat menu. L1 is down here above number 1. So you have to go second, L1, and then comma is right here. Comma, second, L2, comma, and then the same thing that we did with vars, yvars function, y1. Okay, and when you do that, your line should look like this, and you hit enter, and it will do the same thing. So it's giving you the linear regression here, and also the reason we had to put in that yvars, storing it as your function here. Okay, so what we've done is we've calculated the line of best fit. Now when we graph this, we should see the line go directly through those points. Okay, so that's calculating a regression. You might not have done that before. We'll have a chance to practice a few more of those as a class. Our next feature of the calculator that we're going to use, so on the next slide, is finding x-intercepts. So what I'd like you to do is graph this equation, and we want to solve when it equals 0. That, when it equals 0, is an x-intercept. So the first step, type the equation in. We've done this together, so I want you to try that one on your own. Next, you're going to calculate a 0. That one we haven't done together, so we'll take a look. So once you have that equation graphed, go ahead and resume the video. So I'm going to slide over. This is what your graph should look like. Notice you have to go back to the standard view, or at least looking around the origin, to change your window. So we're going to do second, calculate 0. What is a 0? A 0 is another name for an x-intercept. So over here, second, calculate, above trace is calculate. Option 2 is 0. And then it asks us these questions, left bound. So what that means is we need to move this dot, I call it a little spider because it crawls along the web, to the left of the 0, meaning at an x value smaller than the value that we're looking for. So I've got to go to the left. Now that doesn't necessarily mean above or below. We always use left and right when we're calculating a 0. So I found a point, it's definitely to the left, enter. And now it's going to ask me for a right bound. So that means I'm going to click the right arrow until here, I'm pretty sure, but I'm not 100% sure that it's to the right, so I'm going to click it one more time to be definitely sure that it is to the right of my x-intercept. Enter. Guess, just hit enter again. And that will give you one of your zeros, -5 or -0.5, comma 0. That's an x-intercept. And then we're going to do it again. Second, calculate, option 2. Left bound, but we don't want to find this one. We want to find our other one over here. So I'm going to go all the way over, but stay to the left of my 0. Enter. Right bound, go to the right of the 0. Make a guess just to enter again, and there is 2, comma 0. So my zeros, my x-intercepts for this function are at -0.5 and 2. So as a review, what did we do? After we calculated the 0, we had to pick a left bound by using the right and left arrows. A left bound first, then a right bound, then we hit enter for a third time, and then we can get our solution. So don't mistake your solution. If it has a question mark on the screen, that is not your solution yet. And then we had to repeat it for as many zeros as there were. So this is a squared equation. We can repeat it at most 2 times for that. And those are our solutions that we got. Okay, we can do the same thing if we're looking for solutions that are not on the x-axis. So if we're looking at this equation here, notice it does not equal 0 this time, it equals -3. So we're going to do the same thing. We're going to enter this as y1 and y2. So put 1 in y1 and 1 in y2. How do we get an absolute value sign? Those are in your math menu. You have to go over to numerical, and option 1 is absolute value. So that's math, option 1 is absolute value. While you're typing that in, I'll just go ahead and make sure I demonstrate that as well. So if I go over here in my first equation, I want negative, not minus, -2 math over to the absolute value of x minus 2. If I wanted to type something else, I would have to go out of the absolute value or close the parentheses depending on your calculator. y2, I had changed, I'm just going to change my settings back, -3. And then when we graph that, what we're looking for is where are they equal? So we're looking for their point of intersection. I'm going to go ahead and zoom in so that I can see this more closely. And I'm going to zoom in kind of in the middle, but also a little bit down. Kind of think of what do you want the center of your graph to be. Okay, and then I'm going to, again, second calculate, but this time we're not looking for a 0. We're looking for a point of intersection. That is option 5. So I have to pick the first curve, the second curve, and if you've only have 2 graphs, then you're just going to hit enter 3 times in a row, and that'll give you a point of intersection. So at 0.5, comma, -3. But there's more than one point of intersection, so we're going to do it again. Second calculate, the point of intersection, first curve question mark, second curve, I want to make sure it's a different curve, enter, guess. Well, I don't want that same point again, so I'm going to move the little spider over to the other point so that we can get the point of intersection of the other point at 3.5, comma, -3. In review, going through the slide, we typed them in at y1 and y2. We got this graph here. We calculated a point of intersection. And then again, we have questions. We have to pick our first curve, second curve, and our guess, and then repeat for as many points of intersection as there are. Okay. And our last slide is solving a quadratic inequality. Okay, so first what we want to do is we want to graph this. So we're going to set this as y1. Go ahead and do that. Notice that this is a parabola. And what we're asking for is when is this parabola greater than or equal to 0? So equal to 0 were those 2 x-intercepts. Greater than 0 means positive, above those x-intercepts. So we're looking for where is the graph above the x-axis. Okay, so the first step is to find out where do these equal the x-axis. And so again, you can do that using the methods we just looked at or algebraically as a reminder. We would then set it equal to 0, factor it out, and then look at the 2 factors. I just put the same step twice here. But set it equal to 0, factor it out, and then look at as many solutions as there were. Second degree equation should have 2 solutions, but those are just the zeros. So then if you don't have the graph, you have to test the intervals. If you do have the graph, then you can say, is it above or below the x-axis? I don't want the part below because I'm not looking for less than 0, I'm looking for greater than. So above the x-axis is going to be from -4/5 to the left and from 3 to the right. And the way we write that in interval notation We start always from the least number, which is negative infinity in this case because of the arrow, up to negative 4/5, including that point because we have the equals, and then also union from 3 all the way with the arrow to infinity. Written much clearer, typed out on the screen there. Okay, so this is kind of a little reminder of a few algebraic techniques, but mostly getting familiar with your calculator. I have a few practice problems posted on Blackbaud for you to try and upload your work to. But if you have questions, always feel free to email me and let me know.